Finding a hoodie that lasts through the season can be tough. The American Giant Classic Full Zip hoodie is made to last a lifetime, so you can count on it year after year. The iconic Classic Full Zip hoodie is the jacket that started it all for American Giant. Custom heavyweight fleece and side panels for mobility make it the best hoodie ever. Every American Giant piece is made in America and designed to last. No exceptions. The result is durable clothing, like the premium Slub Crew Tee, No BS high-rise pant, and slim roughneck pant that become part of your life. Snag the hoodie that will bring you comfort for life. The American Giant Classic Full Zip. Save 20% off your first order at american-giant.com when you use code STAPLE20 at checkout.
A brand new Armada survey vessel from Ocean Infinity has left its shipyard in Vietnam and headed south. I'll tell you what that means for the seabed search, and I talk about the first of the three pillars of certainty that underpin investigators' belief that MH370 must be in the southern Indian Ocean, and why that belief could actually be wrong. That's all coming up right now. Hi everybody, Jeff Wise back with you with another episode of Finding MH370, the only podcast where we dive deep into every aspect of the technical evidence that will allow us to solve aviation's greatest mystery with inputs from some of the world's most esteemed subject matter experts. First of all, I want to issue a correction to last week's episode. It's a subtle point, but an important one because it goes to the heart of why the search for MH370 has failed. Last week, I said that Australian search officials were absolutely convinced that the captain, Zahari Ahmad Shah, must have flown the plane into the remote southern Indian Ocean. This prompted Paul Kennedy to respond in the comment section of the show page. You can see his actual response here. Kennedy, you'll recall, was the project director of Fugro's seabed search. This was the original seabed search carried out on behalf of the Australian government, which ran from 2014 to 2017. So he was in a position to understand in great detail what the logic for the search was. Kennedy wrote in his comment, Jeff, in relation to your statement, they are absolutely and 100% convinced that the pilot hijacked the plane. That really is not true. Until they find the plane, they do not know 100%, not even 50%. There was a co-pilot there, maybe a passenger. I hoped you would have more journalistic integrity. This is not a reality TV show. It is real life, and the captain has a real family, so please do not be judge, jury, and executioner of his family. That is not right. He went on in a subsequent comment. He added, at no time was your 100% assertion made by any of the tripartite governments. Nailing the pilot to the proverbial cross is very unfair, as there is no solid basis for this assumption. Kennedy is partially correct. The 100% certainty that I refer to wasn't that it was Zahari necessarily who took the plane into the southern Indian Ocean, but rather that someone flew the plane into the southern Indian Ocean. Zahari is widely considered to be the most likely suspect if that kind of scenario took place, but he is not the only possibility, as Paul rightly points out. It could conceivably have been the first officer, Farik Abdul Hamid, or even, as Kennedy notes, someone else on board the plane, maybe a passenger. What's really important, and the point I was trying to make, was that when the DSTG calculated their endpoint probability distribution on the seabed, they assigned a 100% probability to the idea that someone flew the plane into the southern Indian Ocean. That's what's crucial to what I'm going to be talking about in this episode and the next two ones. That sense of ironclad certainty that the plane could only conceivably be in the southern Indian Ocean. In my defense, I will push back against Paul's statement that, as he quoted, at no time was your 100% assertion made by any of the tripartite governments. Here's a clip of Tony Abbott, who was the Prime Minister of Australia when MH370 disappeared, speaking with Sky News in 2020.
Australia's Prime Minister at the time, Tony Abbott, has revealed exactly what the Malaysians believed within a week of the plane's disappearance.
My understanding, my very clear understanding from the very top levels of the Malaysian government is that from very, very early on here, they thought it was murder-suicide by the pilot.
They said that to you?
I'm not going to say who said what to whom, but let me reiterate, I want to be absolutely crystal clear. It was understood at the highest levels that this was almost certainly murder-suicide by the pilot, mass murder-suicide by the pilot.
That being said, I am deeply grateful to Paul for reaching out. When I responded to his comment, I said that I would love to have him on the show to get his perspective on the search. And right now, I would like to extend that invitation again. Paul, come on the show. Let's talk about it. Okay, and now the second part of the show is the latest news about the search from Kevin Rupp, who is, of course, as frequent listeners and viewers will know, he's the go-to source for everything related to the seabed search for the wreckage of MH370. On February 20th, Kevin tweeted that Armada 8606 has departed Vietnam and is headed south towards Singapore. We are watching. On the 22nd, he clarified that, quote, 06 is the only Armada vessel that could possibly continue the search. And then on the 23rd, he wrote, Armada 8606 has arrived in Singapore. We should know in a few days if it is going to head south. Well, it didn't. On February 25th, he wrote, Armada 8606 is departing Singapore with its destination set to Vung Tau, Vietnam. In reply to that, I wrote, is that it then? And he answered, yes, I don't see any other boats capable of getting into position before the weather turns. To which I replied, right, and given the 18-month contract window that Malaysia described in December 2024, it seems likely that no more searching will be done before the contract concludes. Kevin replied, I tend to agree. I am completely at a loss to explain why they quit and why there has not been an announcement. So that might be it. The search could be over for good, like maybe forever. The reason I say that is that when the Malaysians announced the new search effort in December 2024, as I alluded to earlier, they said that it would cover an 18-month period. It's now been almost 12 months since the contract was signed last March. That means 6 months remain, but that time period covers the winter months in the Southern Hemisphere when last year they decided that it was too stormy to permit search operations. So unless Ocean Infinity changes its mind about operating in stormy weather or Malaysia changes its mind about the terms of the contract, we might just have run out of time. And that's it. Honestly, it's been pretty disappointing. It's been a disappointing performance. In 2018, operating out of a ship called Seabed Constructor, Ocean Infinity ran a flotilla of 8 AUVs, and they covered more than 100,000 square kilometers in about 4 months. This time out, from a starting date of February 23rd, 2025, they operated a fleet of just 3 AUVs from 2 different ships, and they accomplished just over 7,000 square kilometers in a time span of roughly 11 months. That means that they took about 3 times as long to cover 1/15 as much ground. Will they come back? It's really hard to say at this point. Honestly, it's hard to say why they even carried out this iteration of the search at all. Malaysia had said that they would only greenlight a search if new and compelling evidence became available, and in all honesty, that did not happen. What there was a refinement of the analysis of existing evidence that suggested a most likely place to look that was really just an extension of the area that had already been searched. It was a low probability area, and it should have not surprised anyone that it was unsuccessful. Ocean Infinity itself seems not to have been particularly motivated based on their performance. They didn't use up all their time. They only searched about half of the area that they said they were going to scan. And now it looks like they've picked up their toys and gone home without even any explanation. Okay, let's move on to part 3 of today's episode. This is the main course in which we unpack the first pillar of certainty that has underpinned the Southern search. This pillar has to do with the physical evidence in the case. Now, with the first 15 months after MH370 disappeared, there was no physical evidence, none. The only evidence that existed at all was a mathematical analysis that had been conducted on a set of radio signals, the likes of which no plane had ever generated before or since, that arose as a result of an electrical event that no one could adequately explain. It seemed, frankly, like a very, very thin thread on which to say that 239 people must be dead. But then suddenly, in July of 2015, the first physical evidence emerged.
Major discovery on the tiny French island of La Réunion, which is about 600 miles off Madagascar and in the Indian Ocean. That debris that was found on the beach in Réunion, as we say in English, now definitely appears to be from a Boeing 777, and there is only one 777 missing anywhere in the world, and that, of course, is Malaysia Flight 370.
The discovery of a part of the airplane floating in the ocean seemed to confirm at last what that strange data had implied all along, that the plane really had crashed into the ocean. But more than that, investigators hoped that it might guide them to the plane's location.
Undertake the very difficult task of trying to now backtrack exactly where this debris might have originated. In other words, looking at ocean currents and patterns over the last 16 and a half months to see if they can get some sense of where this particular piece of debris might have originated. That's a huge challenge. They will also be looking at the sea life, the barnacles that are on that wing flap, to get a sense of where is that sea life originating. They might get a sense from marine biologists if that particular sea life is unique to a particular place in the Indian Ocean.
These barnacles, specifically goose barnacles or Lepus antitifera, have shells made of material whose chemical composition changes depending on the temperature. If investigators knew the temperature of the water in which the barnacles had started growing, that would imply a latitude. And the intersection of that latitude with the seventh arc would tell them where the plane's wreckage would be found. But had the shells been growing during the whole time the flaperon was in the water? That turned out to be a tough question to answer because at the time, there had been very little scientific study of Lepus antitifera. These are creatures that don't have any commercial value. They're basically just a nuisance that grows on ships and moorings and things. It just hadn't seemed very important to anyone before. But the French scientists went digging and they found one scientific paper from the 1950s that described how some Lepus barnacles had grown on the hull of a ship during a passage from Dakar in West Africa to Barbados in the Caribbean. Over the course of 107 days, the barnacles grew to a length of 25 millimeters or 2.5 centimeters. In comparison, when scientists studied the flaperon, they found that the longest was 3.6 centimeters long. Drawing a curve, and they basically came to the conclusion that it was entirely reasonable that after 15 months, that is how big a Lepus barnacle should be. Well, in the years that followed, more research was done into Lepus growth, and some interesting facts emerged. A research team led by Martin Stelfax in Mauritius in the tropical western Indian Ocean grew Lepus on moorings to see how fast they would grow. I actually interviewed Stelfax for episode 24 of season 1 of the podcast.
And the idea that, oh, hey, these things actually are sort of a store of information about the environment. Maybe it's a clue.
It's a pretty good indicator to give us an idea of how long things have been drifting for.
So if your aim is to use Lepus, a community of Lepus as a kind of clock, it would be nice to have a kind of a baseline to understand, a kind of reference population that you know how long it's been growing for. You used these fixed, you grew them on buoys, I guess, basically, because, practically speaking, you can't just go drift around the ocean. But if you had a kind of reference of something that was floating in the ocean in those same waters, that would be a very useful baseline, wouldn't it?
Yeah, if you could potentially look at a way of tracking any sort of material over time, and taking samples over specific time intervals as it's naturally drifting with currents. That would be a bit more accurate. Obviously, what comes with that is cost. It would be a very expensive experiment because you'd need the resources to be out at sea and then also the resources to track it through technology as well.
So I think the idea that I think people should understand, and correct me if I'm wrong, is that these barnacles do grow at a fairly reliable and predictable way, but within the context of a given environment. But if you put them in a certain environment, then they can be used as a clock. But you need to have a reference to understand how they grow in that environment.
That's right. Yeah, I mean the different environmental conditions that barnacles are exposed to will dictate certain kind of variables within how you predict a growth pattern.
They found that the size of the average barnacle that they tracked followed a growth pattern that looked like this. Notice that at the end of the 3.5-month study period, the average barnacle was 2.8 centimeters long, but the longest barnacle was 3.5 centimeters long, which raises the question, when we're talking about how big barnacles are on a given object, what are we really talking about? We could talk about the average size of all the barnacles, but that can be very cumbersome if you have thousands of barnacles on an object, which can happen. An alternative is to just talk about the longest barnacle because it's easier and it focuses attention on the one that is probably the oldest, and so closest in age to the amount of time that the object has spent in the water. That's what we really want to know. There are some drawbacks to this approach. I won't get into tedious detail, but for present purposes, because we want to compare apples to apples, let's stick to that one approach. We're going to be looking at the longest barnacle in a population as a proxy for how old it is. Okay, so now we have a data set that shows how one population of barnacles grew in one part of the ocean. Does that apply to all cases? Well, in brief, no, it doesn't. Because some other researchers found that lepus grow at different rates depending on where in the ocean they are. Australian researchers grew lepus on buoys near Sydney. They found that the buoys grew more than 4 centimeters in just 1 month. Whereas on the western coast of South America, barnacles grew to a maximum length of less than 2 centimeters. So it seems like one important assumption that the French researchers had made was wrong, was that lepus don't grow at the same steady rate all over the world. Maybe a ship going from Dakar to Barbados is going to experience lepus growth rates the same as would be experienced in the southern Indian Ocean. That may be possible, but we can't assume it. In fact, we don't even know if they grow at a consistent rate, period, even within one particular part of the ocean. And if they don't, then we can't really use their size as a measure of how long something has been in the water. One way to address this question would be to study how lepus grow in one particular stretch of ocean and compare how they grow on multiple different objects to see if they grow at a consistent rate. Well, one experimenter was able to do just that. Cynthia Venn is a retired marine biologist who worked for many years at Bloomsburg University in Pennsylvania. Years ago, she was approached by researchers at NOAA, the National Oceanic and Atmospheric Administration, who were maintaining a grid of buoys anchored in the deep Pacific along the equator, above and north and south of the equator, actually. The goal was to collect water temperature and other data that would help scientists understand the El Nino weather pattern, which obviously has such a big influence on global weather. So every year, these researchers sent a ship to check on the buoys, maintain them, and replace them as need be. And every time they went to work on the buoys, they found them absolutely covered in lepus barnacles. So researchers at NOAA offered to collect these and give them to Cindy in her research. And as a result of that, Cindy wound up with literally hundreds of thousands of these shells. Recently, Cindy shared with me a subset of her data. One of her students had gone through and measured one by one the length and width of thousands of lepus collected from 10 of these buoys. This is what the size distribution of those populations looks like. Just looking at the length of the biggest barnacle on each buoy, the longest was 5.7 centimeters. The shortest was 3.9 centimeters. The fastest growing was collected on buoy that was designated ET466. It had grown to 5.7 centimeters in just 142 days, or 6 months. The median length was 5 centimeters. Of all of these 10 buoys, the median length was 5 centimeters. The median age was 350 days, or about 1 year. Not surprising. That's how frequently they went out to maintain the buoys. So it does seem that there is a certain consistency to how these creatures grow, with a certain amount of variation, but that allows us to handle it statistically. And that's a good thing. That is encouraging, based on this, what is admittedly a limited set of data, but it's a preliminary result. So one thing that's interesting to note is that there doesn't seem to be a connection between the length of the longest barnacle on each buoy and the amount of time it's spent in the water. This suggests to me that the barnacles are basically reaching their maximum size in less than 6 months, at least in this part of the tropical Pacific. So if we want to use the size of Lepus as an indication of how long something has been floating in the water, we can only do so if that time period is less than the time that they require to reach their maximum full size, which seems to be 6 months. So in general, we can't just look at Lepus and say, tell me how long this object has been floating in the water. What we can say is, has it been floating for less than 6 months? And if so, for how long? The answer is only going to be probabilistically true. So for example, if we find that an object is roughly the same size as a buoy and its longest barnacle is less than 3.9 centimeters, then that means that there is a statistical likelihood that it has been in the water less than 6 months. Now, there's a big caveat I'd like to attach to this data set, which is that it looks at barnacles growing on tethered buoys. These are buoys that are floating, anchored to the seabed. At this point, we don't really know if barnacles grow at the same rate to the same maximum size on free-floating objects like a flatbron. The way that barnacles feed is they attach to something solid and they sweep up food particles that drift past. So an object that drifts with the current might not see as many particles drifting past as one which is held stationary in the middle of a current that's flowing past it. So maybe Lepus will grow bigger on buoys than they do on free-floating objects. That's a possibility that we're unable to answer at this point. Okay, so unfortunately, it's really hard to study objects that float randomly around the ocean, because they're, generally, in many cases, thousands of miles from land. They move in random directions. If you want to track a free-floating object, you basically would have to spend months, chasing it around out in the open ocean. I don't think I need to explain how impractical that would be. Frequent viewers of this podcast will know, of course, that there is a different way, which my guest, Andy Sabrandi, suggested during his appearance on episode 12. The idea that he proposed was that we could look at buoys that are part of the Global Drifter Project, these are buoys, scientific instruments that have been dispatched, part of a program overseen by NOAA again. These are floating around in the ocean, transmitting their location and other data via satellite once per hour. Their locations are displayed on a public website, so if you want, you can follow them, as I in fact have done, and wait until they come ashore somewhere, and then look up on Google Maps and see what if there's a hotel or a dive shop or something nearby. And you can ask someone to try and go collect that buoy. And if you do, you'll have a population of Lepus that has a known history of time in the ocean because it has been transmitting its location by satellite. So the first time I tried this, I described the results in episode 16. The owner of a lodge on the Kenyan coast was able to retrieve the buoy, but someone else had already found it and stripped off the barnacles. So it was a partial success at best. We finally hit pay dirt in episode 40 when the proprietors of a stand-up paddleboard tour company in Zanzibar, Twins, were able to retrieve a buoy that was totally covered in lots of big, beautiful lepus. We had our first really good data set. That was last fall in October 2025. We went on from there. To date, we have collected 1 from Hawaii, 3 from French Polynesia, 3 from Australia, 5 from Tanzania and Kenya, and 3 from Madagascar and Mozambique. My most recent one was earlier this week, just a few days ago. Marine park rangers on the coast of Mozambique were able to collect one that came ashore in the Vilanculos Coastal Wildlife Sanctuary. Unfortunately, as had happened in Kenya and has happened many times, someone had gotten to it first and stripped off the barnacles, as you can see here. There was some left, but we can see that this pretty plainly shows the drawbacks of this approach, which is that in the process of coming ashore and being collected, these lepus populations can suffer some pretty significant damage. I would say that the majority of the buoys that I've collected have been found in what appear to be severely degraded conditions. In some cases, the people who found the buoys told us that they stripped the barnacles off, but in many cases, we don't know. It could have been predation out at sea. It could have been mechanical damage as waves bashed it on the reef or the sand of a beach. It could have been, cleaned by a human who found it first. It could simply be that the particular buoy, the barnacles just didn't grow as well or as quickly as on other buoys. We don't know. But what's pretty clear is that if you look at a bunch of these, what I call disrupted buoys, they tend to have significantly smaller barnacles. Taryn Gilroy is the manager at the Vilanculos Coastal Wildlife Sanctuary who arranged for the buoy to be picked up earlier this week. She sent me a photo of the barnacles that they recovered lying alongside a ruler. By using a piece of software called Fiji, I was able to determine their length. The longest one is 2.9 centimeters. Now, this is a buoy that's been at sea for more than 2 years. So this is not a population that's still growing. This is what I see this time and time again. The buoys that have patchy and sparse lepus on them, when they're collected, have smaller lepus. What seems to happen is that when you take enough of a population away, you're statistically going to lose some of the outliers. You're going to get reversion to the mean. It may even be that predators go after the bigger guys preferentially. Maybe the bigger guys stick out more, and so they're more likely to get abraded off on that beach or reef. We don't know. For the time being, let's turn our attention to buoys that have what look like undisturbed populations. One of these came ashore on the French Polynesian island of Rangiroa last November. It washed ashore on this stretch of remote reef. Fortunately, in this case, there weren't a lot of beachcombers wandering around. It stayed there for a while before some staffers from a hotel called Moana Breeze went and retrieved it. They carefully counted and logged all of the barnacles. They found about 2,000 of them. So thank you for all your work, staffers at Moana Breeze. Really appreciate it. Now, what's particularly interesting about the buoy is that after it was deployed, it floated westward, not too far from the equator, on a stretch of the ocean that's pretty similar to the area where Cynthia Venn's buoys were anchored. So it's interesting to compare their sizes. The biggest barnacle on the Rangiroa drifter buoy was 3.85 centimeters, which is nearly the same as the smallest of Cynthia's barnacles. Coincidentally, it had spent about the same amount of time in the water, about a year. So that tells us that based on this very preliminary set of data, there's an overlap between how lepus grow on free-floating and moored buoys in a given patch of water. Maybe drifting buoys grow slower overall. We just can't tell yet. We need to collect more data. You're going to hear me say that a lot. Now, let's compare the Rangiroa lepus population with the one we got from Zanzibar last October, which is in the western Indian Ocean. Similar latitudes, different ocean. Do they grow at the same rate? Well, the longest barnacle on the Zanzibar drifter was 4.6 centimeters, so significantly larger, but well within the range that we observed on Cindy's moored Pacific buoys. So it could be that free-floating objects in the tropical Indian Ocean follow a similar growth pattern as they do in the tropical Pacific, or maybe they grow a little bigger. TBD. I need to get more buoys. Buoys that have these undisturbed populations on them. There's a couple of ideas that I've been playing with that I think might work. One would be to approach people who are about to go on a long voyage across the ocean, similar to that ship that went from Dakar to Barbados. Ask them if they could periodically check their hulls. For instance, sometimes people try to row across entire oceans, and the hull of a rowboat would be a great place for a lepus to attach. When Cynthia Venn was doing her work, she was approached by a paddleboarder who was crossing the Pacific and periodically collected specimens for her from his hull. Another idea might be to approach some of the marine research institutions who work in the Indian Ocean and see if they might be willing to deploy buoys that we could retrieve later. At any rate, there's lots of opportunities to gather more data that will help us understand how lepus grow in the open ocean, and hence to use them forensically to figure out how long things have been in the water. But that's not really what we're here to talk about today, is it? What we really want to know is what all of this new information tells us about MH370. Well, to my mind, most of MH370's debris that was collected was in what I would call a degraded condition. Either there were no barnacles at all, many had no sea life at all, or just a few barnacles like this one from Rodriguez. It only has a scattering. The biggest was just 2 centimeters, which is pretty typical for an object that's as degraded as that. Only 2 of these several dozen pieces that were, collected and believed to be associated with MH370, only 2 of them had what I would call undisturbed populations. The flaperon and the Roy piece that washed ashore in Mossel Bay, South Africa, December 2015. Now, when the French published their findings on the lepus from the flaperon, they described the longest as being 3.6 centimeters, but they also released images of that shell alongside a ruler, indicating that if you measure the shell in a standard way, it's actually 3.5 centimeters. This is smaller than any of Cynthia Venn's shells. If we assume that it's part of the same normal distribution, then less than 1% of objects will have a maximum barnacle size this small, like 0.75%. So not an impossible eventuality, but a low probability one, if the Venn data is truly applicable to the Western Tropical Indian Ocean, and that is a very big if at this point. It seems problematic that the flaperon's barnacles should be this small. It does raise the question, is this a population that spent 15 months in the ocean and just happened to be small? Or is it a population that is less than 6 months old and is still growing? As I pointed out in earlier episodes, based on the Stelfox findings, we know that a population in that part of the ocean can reach 3.5 centimeters in 3.5 months, perhaps even less. So as far as the flaperon is concerned, we find ourselves in a gray area. The flaperon lepus certainly don't prove that the object was in the water for the full amount of time that had elapsed since the plane vanished. But they don't really disprove that idea either. At least not yet with our present state of knowledge. I would love to collect more data so that we can really nail down our understanding of how these creatures grow. It may be that we can use size distribution to tell the difference between younger and older populations. What do I mean by that? It may be the case that if you have a population of young lepus and it's getting older, more and more individuals will approach that largest size, and then their growth will slow. On the flap run, there was only one single individual in the top 10% of size, meaning that in this case, bigger than 3.15 centimeters, between 3.15 and 3.5 centimeters. There was only one barnacle that big. Compared to the Zanzibar buoy, that there were 7 in the top 10%. That, remember, was in the water for 10 months. In the Moana breeze, which was a few months older, again, there were 18. So you have 1, then 7, and then 18. That's just a hypothesis. That's just an idea. I would say that with regards to the idea that the flaperon could only have wound up on Réunion Island because it floated there naturally from the crash site, there is absolutely no reason to think that that is the case. If we're open to alternative scenarios, then it's very easy to imagine someone who has hijacked a plane, putting pieces in the ocean for a little while until they grow some marine fouling organisms, and then allowing them to be found on the shore. This would be trivially easy to accomplish. In fact, if we were to look at the size of Lepus alone without prejudging which scenario is more likely, then they seem to fit better at this point, much better, with a planting scenario than with a natural floating scenario. I want to talk much less substantially about the Roy piece. It's interesting. This has a thick population all the way around on those jagged edges that lepus like to attach to. It seems that this piece has come ashore with very little disruption at all. Officials even took a picture of it after someone had cleaned off the barnacles, so we know how big it is. Eyeballing it, it looks to me like the barnacles are smaller than on the flaperon, but I can't really tell for sure because the image with the barnacles is so distorted by the camera angle. It's also, I think, slightly curved, so it's hard to do simple photogrammetry. I tried to have my son help me out. He's very good with Blender, and we tried to project one onto the other. We were struggling. So if there's anyone out there who's a Blender expert or just good at photogrammetry and would like to help solve the mystery of MH370, here is your chance. Reach out. Let me know. My phone line is open. Okay, so to recap, today we've looked at the third pillar of certainty, the certainty that the flaperon and all the other pieces of debris must have floated from an impact site in the southern Indian Ocean. What we have seen is that, on the contrary, the barnacles are rather smaller than we would expect to see in that scenario, which means that it's entirely conceivable that the barnacles are less than 6 months old, and that a possible explanation for their small size is that they were planted after the fact by whoever took the aircraft. I'll leave it there for now. It's been a lot to digest. As promised, in the next 2 episodes, I'll be looking at the remaining 2 pillars of certainty. It's just going to get wilder. So stay tuned. In the meantime, leave your questions and comments here. You can also do so at the show page at findingmh370.com, where you can also sign up for a free newsletter that goes out with every episode. Love to hear your thoughts, questions, comments, suggestions. Just shoot them at me. For now, this is Jeff Wise. I'll see you next time.